Alright, so you remember your sine, cos and tan ratios? It's written on the top here, so if you need to you can always just write it back down. Alright, so calculate to do the sum of places, the values of each of the numerals. Now, looking on the first one, what's this part?
The hypotenuse.
Yeah, so the h is the hypotenuse. What's this one?
The opposite.
Opposite, good. So you have hypotenuse and opposite. Which one has hypotenuse and opposite?
Pardon? Sorry.
Which one has hypotenuse and opposite?
Yes.
So h and 10. So then how do we solve that?
You stop the h in the same body.
Very good. Okay. Now this asks you to write it in 2 decimal places, but if you need to write it in exact value, that's the exact value answer. Okay? I don't have a calculator. You have one? Thank you. Alright, so part B. If we're looking at part B, and we need to find the angle A, we need to do something first. What do you think we need to do first? Yeah, good. So we need to find this side first. So how do we do that? Pythagoras, very good. So c squared equals to 8 squared plus 6 squared. And then this is actually just a Pythagorean triad. So if you know what it is, it should be 10. Then once we have the fact that it's 10, what ratio do we have? Sine, cos, or tan?
Sorry, 10.
10, very good. So tan of A is equal to the opposite over the adjacent, so 12 over 10.
Take 10, negative 1 over.
Very good. Oops, 6 over 5. We get 50.19 degrees. Now, this is also the exact value answer if you need it. Okay? A line segment AB is inclined at an angle A to the horizontal, where tan theta of A is equal to 1. Now when you have a question like this, you need to look at the different sides, because if you think about it, tan theta is actually equal to the opposite over adjacent, right? So if you have a look at it, the opposite is equivalent to a 1, which means you can write a 1 there, and the adjacent is equivalent to a 3. So this means we can actually find out the other side, the missing one, which is the hypotenuse. How do we do that? Yep. So c squared equals to 1 squared plus 3 squared, and this time we'll actually get a third for an answer, which is square root of 10. Alright. So then if we want the sine of A, we already have a triangle, so we simply just fill them in. What is sine?
Opposite over hypotenuse.
Yep, so the opposite is 1, and the hypotenuse is a square root of 10. Now, you might be asked to rationalize. Do you know how to rationalize? To rationalize, see that surd on the bottom? You multiply whatever that is. Obviously, this is slightly different if you have a plus or minus in between, but we'll explain that if we need to later. Okay, so long as the bottom isn't a surd, you've rationalized it. Okay. I should probably label it AB like this first. Alright, calculate the vertical height of B above the horizontal through A if the length of AB is square root of 5. Now we have a ratio of, if we pick any of the ratios, doesn't matter which one, well, it kind of does. we need to pick one involving a, b. Now I'm just going to use the one from sine earlier on, where we have root 10 over 10. If we read this question, we can draw another triangle, AB, like this, and we want to find the height here. I'll just call that x. So we can't actually use sine. Oh no, it is sine. Alright, now we know that this is square root of 5. This is on the opposite side, so we can use sine. It's opposite over our hypotenuse in this case. Then we just rearrange to find x. So times root 5 on both sides. So then you have square root of 50 over 10 equals x. Now, if you don't remember how to solve that, the third can always be simplified to its squares. So square root of 50, there's a 25 in there because it's 25 times 2. Then, what's square root of 25? 5. Then what can we simplify? The 5 and the 10, right? So we get the square root of 2 over 2. That's our exact value. Okay? Alright, now there are actual exact values that you need to memorize, and there's two ways to do this. Number one is using the table. So if you have a look at sine, if you look on the top, it goes from 1 to 2 to a 3. They're all over 2. Do you see that? Now, easier way to remember it, square root of 1 over 2 is the same as 1 over 2. That's the reason why it's just 1 over 2. But you can just remember it as square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Once you remember sine, it's easy to remember cos, because cos just goes the other way. So once you've written out all the sine ones, cos just goes backwards. So you can see that that's a half, then that's root 2 over 2, and that's root 3 over 2. Then, once you've found sine and cos, you can just find tan, because tan theta is equal to sine theta over cos theta. So that means if you take the 30 degrees, for example, we have a half over root 3 over 2. Now it looks hard, it's okay. The bottom of the fractions actually cancel, so we're left with 1 over root 3, which is right there. The other way of remembering this is there are two triangles that you can remember. The two triangles are, one's an equilateral triangle, which is this one, then you cut it in half. The other one is an isosceles triangle with that side and that side being equal. Because it's an isosceles triangle and it's a right angle triangle, if you have 90 degrees there, these two are going to have the same angles because the angles always match the sides opposite. So that means that's 45 degrees and that's 45 degrees. Then you can write out your sine, cos, and tan by knowing which side of the triangles it is. This is similar, but each of our sides is a 2. So like I said before, it's an equilateral triangle of 2, 2, and that bit is a 2. But like I said, we cut it in half. So the 2 becomes a 1 on the bottom. The side is a 2, then using Pythag, you can figure out that bit in the middle. Okay? Then once you draw it out, the sides match the angles again. So root 3 is bigger than 1. Root 3, if you need to, is approximately 1.57. And root 2 is approximately 1.21, if I remember correctly. So because 1.57 is bigger than 1, you'll have the bigger angle on the opposite side. So the one opposite root 3 is a 60, the one opposite of 1 is a 30. Okay. Alright, now what are these used for? At the moment we're just going to use these for application stuff. So a ladder of length 4 meters is leaning against a fence perfectly somehow. I have no idea how it's staying up. Anyway, if a ladder is inclined at 30 degrees to the ground, how far exactly is the foot of a ladder from the fence? So foot of the ladder to the fence will be x. The ladder is 4 meters, and then we have 30 degrees. So, how do we find x? What ratio do we use?
Cos.
Good. Oh, wrong way, wrong way. Alright, now, what's cos of 30 from the screen before?
1/8 square, sorry, root 3, was it? Oh, 3.
Close. Close. You're on the right track. Alright, then just times 4 on both sides. So then 2 root 3 is the same as x. Ooh, writing down meters first would be good. Alright, so area of a triangle. If you do general, you would have seen some of these before. Half base times height, that one's a standard one. The other one involves sine. So with that one, I need to draw a triangle out to show you what it looks like. So if you have A, B, and C, because the sides opposite it match the angles, at angle A, we'll have side A. Across angle B, we'll have side B. Across angle C, we have side C. I'm going to use a cursive one. Alright, so long as you have two sides and you have the other angle, which is this one, you can find your triangle. So, calculate the exact area of triangle ABC for which we have these three things. So we have A, B, C, that's 60 degrees. Then the side across it is square root of 62. The side across B is 5 root 2. The side across C is 6 root 2. And then now we write out, because we have an angle, we have to use the area of a triangle formula for this one. So let's write it out. Now we might have to change this a little bit because we actually have angle A. So let's write the sine A part first. If you notice, these two letters are the other two letters. So we have B and a C, and we times it by half. So half times, now remember B is the one across B, so we have 5 root 2. C is the one across C, so we have 6 root 2. Then times sine of A, which is 60 degrees. Okay. So then we have a half times 30. I'm just going to separate the square roots with the normal numbers. Then we have square root of 2 times square root of 2, which is 2. What's sine of 60?
3 square root of 6, something like that.
That one?
Yeah.
Good. You have it memorized already. Alright, so then the half cancels with the half cancels with the 30 to give you a 15, so we have 15 root 3. That 5 looks a bit dodgy.